It's 55. We can start? Okay, good.
Hello.
Test.
Test.
Perfect. Thank you very much for attending this session. So we are both from Consensys and we work on agentic for the company. And we are doing experimentation. I've contributed for the ERC 8004 for trustless agents. So I'm software architect. And Satya?
Hi, I'm Satyajit Kolhapure. I work in Consensys. I'm a senior software developer.
So this session is a workshop. So you will be able to code, but it will be intense. And you have some prerequisites. So is there anyone that plan to code in parallel? It's okay. I think the best is to code after. If you are convinced about our qualitative presentation, you would be able to code and to do the workshop. But if you want to try at the same time, you can. I will give you the prerequisite and you can try. Okay, get ready with your computer. Everything is settled. Okay. So we have investigated the way to build trustless agents. So trustless agents are agents that are transparent, so with open source and so ability to see what the agent is doing. So in contrast with all opaque agents that are existing today, or also AI services that exist, and also verifiable. So this is leveraging cryptography, and it's how you trust but verify with cryptography what the agent has committed itself to do in a very transparent way. And the last property of trustless agents that we are going to showcase is the trust minimized aspect. So AI agents have agency over wallet, and they will be able to have delegation from a user in order to do some operation. So the idea here is to do the enforcement of the permission at the settlement layer, so at the blockchain layer. So we are talking about agents for end user, so real user at scale. It's not like your personal agent that you will use for your own good, but it's agents that you will be able to deploy and run a business, or that will be able to interact with thousands of users of millions of agents in a trustless manner. So for building these agents, so we are going to surface some stack that we feel that was optimized for what we want to show. So first, we are going to leverage LangGraph for the agentic runtime, X402 for the internet native payments, on-chain delegation for permission granting to agent, and ERC 8004 and TEE for verification and discovery of the agent. Okay, so for those that want to follow up, there are a lot of prerequisites. So you need to have Node.js, PNPM package manager, and you need to have API key for an LLM, so your favorite LLM. And we are using a smart account, so you need a bundler access, so Pimlico, and you need some if. So if you feel that you will be able to follow and having all these prerequisites, go ahead. But otherwise, you can just scan the GitHub and you can do it afterward. I give you a few minutes, seconds. Okay. Okay, good. So let's have a quick overview of this landscape. So we try to surface what are the trustless agent building blocks. So here we define some layers. So we have, of course, the interfaces layers. So how the agent can interact with human, with chatbot, for example. How the agent can interact with other agents, with A2A, MCP, and so forth. Then you have the agentic layer. So it's all the reasoning of the agent, all the execution of the agent, all the routing of the agent. So all the the runtime. Then you have the settlement on verifiable state. So here you have like the settlement and the agency of the agent with his account and the ability to delegate with smart contract and also register on chain and so forth. You have all the cryptographic aspect with creation of private key, having the proof, like the different proofs you will need for this trustless agent, and the infrastructure dimension. We have surfaced here all the trust models because each of those, so for example, for the settlement on verifiable state, you have blockchain, and here you have everything that is verifiable and so forth. But for others, you have different quality of trust with like cryptography, with authentication capability-based solution and so forth. So I will let Satya just give an overview of each stacks that we are going to use that are covering those different aspects.
Yeah, so for the limited time, we decided to use the subset of this stack. So for the interaction surface for the user, we are using Telegram and Discord, and we are exposing the endpoint with the A2A. For the agent computation layer, we are using LangGraph and LangChain. This LangGraph is basically one of the many famous tools used for the developing the agent workflow. And I'll explain a little bit in brief why we chose LangGraph in the upcoming slides. In the settlement verifiable state, we are using MetaMask delegation toolkit, like MetaMask smart accounts. For the identity registry, we are using 8004 Agent 0 SDK, which can perform operations on the 8004, like a registering agent, and etc. etc. For payments, X402 ERC20 tokens, and for the cryptographic control plane, we are basically deploying our agent on the Egan compute and VM basically for performing the blockchain operations. And we are executing all these transactions on base L2, but just because I mean it's probably compatible with X402 and ERC20, but it works on any L2.
Thank you. So let's build. Okay. So in the repo, you have a README that will help you to go over the different steps in order to run the workshop. So the first aspect is to understand the project structure. So in the repo, you have the source and you have the workshop correction where you have everything implemented and the workshop. So those are the prerequisites. In order to play with this workshop, so first we have implemented some scripts. So the first one is to create smart accounts. You just launch through PNPM the create function. So we are using Vim to create the smart account. And then we are going to test it with a hard-coded prompt in order to test that our trustless agent is working correctly with like basic setup. And then we will launch an agent with an HTTP server in order to make it accessible by anyone, so it can be an agent or a human. And at the end, the registration process to register the agent in the ERC 8004 identity registry. So let's start with the environment variable. So you need to come up with your LLM API key. So we are using OpenAI. Longsmith is a monitoring tool in order to be able to monitor all the reasoning of the agent in the workflow. So we'll see this after. Bundlers, so they enable to tackle smart accounts. So it's a smart contract and smart account transactions that are managed here. And since we are use delegation, we need this. And in our example, we will have one first persona that is a user, a human user. So here for the user, we have its smart account address and its EUA address. Then this user will interact with an agent that have its own address as well. And this agent will interact with another agent that will be the final agent that will do the final service that we want to offer. So it's just to illustrate that we can delegate with a chain of delegation. A target address just to send like phone to this address. So once all those environment variable set up, you can start the workshop. So the entry point is in the index file. So in the index file, you have the entry point where you can launch the different command I showed before. So we'll start with the test part. So test is just here. We have the agent runtime that we are going to invoke with a human message. So it's a static message where we transfer a certain amount of if. So, okay. We go to the agent runtime where we have implemented the agent. So if I start and test the execution, we have an error that if you will do the workshop, that will say, okay, we need to implement the invocation of an LLM. So we are building an agent. So agents are working with LLM. So we are using long chain and long graph. So long chain is giving a lot of tools to interact with LLM and provide like agentic tool. And long graph is doing the orchestration. So I will code this in order to show you those different aspects. So I use OpenAI. So I will create like just a model. New chat OpenAI. Okay, and this model will have like a few characteristics. So we just copy this to go faster. So you have the model, the temperature that we will let as default, and the API key. So this will be the LLM that we will reuse for different reasoning that will be conditioned by different prompts. So here's the long graph dimension where we have this object that we call the state graph. So this is one of the main primitive of long graph. So basically you add nodes. So here you have my LLM, that is one node, and each node is a function. So we have the LLM, the reasoning, and you have tools. You can add like many tools for the agents in order to fulfill its services. And then you have edges that connect the different nodes together in order to have the different conditions that you want to offer to your agent. And conditional edge is the condition where you decide whether the agent is going to call another agent, is going to call tools, or is going to end the process to provide the final result. So in order to illustrate this, I will let Satya just explain all this mechanism with this workflow mechanism offered by LangGraph.
Yeah, thank you. So, hello. Is audible? Yeah, now it's good. Yeah, so LangGraph is one of the, like as I said, is one of the many tools available to create the workflows with agents. In LangGraph particularly, the nomenclature used, like there are some few terminologies, it's very easy. Like there are only two main terminologies in LangGraph. One is node and one is edge. So you can create as many nodes as possible for your requirements and then connect those nodes with the edges. So you can see here there are two yellow nodes which are mandatory, which nothing that doesn't have any code inside. It's just to LangGraph to know that the workflow starts here and workflow ends here. So between that, for our example code, we created one LLM node. The node basically is an agent. It can use LLM or it cannot. Like it doesn't have to. It can only have a pure code. But with our example, as we want to get input from the human, we're going to use LLM to understand what's the requirement. So the LLM node is connected as shown in the code, like the OpenAI model. Because just to give a brief history about LangChain and LangGraph, LangChain was initially created to compete with OpenAI SDK, and it was like in very basic form. Then they evolved into LangGraph. So that's why you can see there are some core libraries used on the LangGraph. So inside that, that's why by default it's using OpenAI model. But if you want to use something else like DeepSeek, you can still use it using the URL parameter. So that's that. LLM node will use the LLM. Then it will basically call the LLM. LLM is not capable basically to do the action. So depending on the message, it will basically conclude if it needs a tool call or not, and then give it back to the agent. Then the conditional age will decide whether the tool is requested or not. Depending on the tool requested, the control will go to the tool node, and then tool node, depending on the array of, basically it will pass the array of list of tools which needs to be executed. Then the tool node will execute the tool, they'll get the response back from the tool, send it back to the LLM. If LLM is satisfied with it, then it will basically go to the end. If it needs more tool calls, the loop will just continue, and you can imagine, you can design these if conditions and make complex systems using the LangGraph. Yeah. One more thing, sorry. The state. To share the information between the nodes, nodes needs to, let's say, pass some information between them, like what's the context happened before. So for that, state is used. In LangGraph, by default, the state is shared only for the one execution. Let's say there are concurrent messages happening between human and this workflow. For that, if you want to keep the track of the state like previous messages, it's just one line of code, just add a check pointer and it will keep track of it. Yeah. Back to Dan.
We can illustrate the states with like the main object that are messages. So basically you can see the state as a collection of message, and you have three kind of messages. You have human message, so it's all the prompts that are coming from an external actor. System message can be like any pre-prompt or any system information that we want to provide to guide the agent with other context. An AI message, it's the reasoning message provided by the LLM nodes, basically. And we can enrich the state with any information. We can structure the state with the needs that we have. So in our case, we manage delegation because each execution of the workflow, so it's an invocation of workflow, we call that, we provide the delegation in order that the agent is able to act on behalf of the delegator. So going back to the code, so state graph, so as I said before, is the main object. First, we need to implement the reasoning. So it's the LLM node here. So each node are a function, and here we have this error that have been thrown. So we need to implement the logic. So let's say I want to give some pre-prompt to my LLM. So I want to say you are a trustless agent that orchestrate on-chain actions. And then I want to retrieve the prompt of the user. So here, as we surfaced it, we can get the state from the messages inside the state. So I go state.messages, and here I will have all the message. So I can console log this in order to show this part. Prompt. Okay. So the next step is to call the LLM with this state as an input. So I will get a response, and I will call the model. So you remember before we called we create this chat open AI object that we call model. So this just call the LLM, and we will do model, and then we will invoke the model, okay, with the pre-prompt that we will instantiate as a new system message, and the prompt here that will be a human message. So it will be a new human message. Okay. And we have the prompt. Okay, maybe here I just do this and it would be good. Okay, you need an array and we are good. Okay. This, I'm not sure about this. Okay. So now I can just re-execute my my agent. So I will run the test. So you can see the human message transfer if to this address. You can see the response of the AI. So the AI is not able to do this transaction because we haven't affected any tool to this AI. So now this is our next step. We will add tools to this to our AI. So we create, so in chain you have the tool node where you can add tools. And here we have implemented a transfer tool. So if we go to transfer tool, basically it's just a function with the logic. We return the response. This will be read by the agent. And in order that the agent decide to whether this tool is relevant or not, the agent will read those metadata. So the name of the tool, the description of the tool, and will provide as input those fields.
So basically, behind the scenes, the LangGraph graph understands this the format of that node, the tool basically, and then it guides that which tool needs to be called. So this is the format. By default, there are so many tools given by LangGraph graph itself, but this is one example of creating your custom node. So you have control over your code.
And this is aligned with different standards like MCP, SKS, and so on. So you can easily, like with the native SDK, add like new tools that are coming from another source and not just implementing you yourself the tool. So here we have the checkpointer is, as mentioned, Satya, is a way to register the state across the different interactions. So now we have the tools that are available for the agent, but first we need to implement the conditional edge. So here we return n by default, but we need to look at the state, retrieve the last message. So here I retrieve the end of the array of the message, and then I do a condition. So where I return I check if the last message in the state is an AI message, meaning that our LLM has spoken at the end of this loops, and I will verify that the LLM asked to call a tool or not. If not, we end it. If yes, we call the tool node. And then we will have another loop where the agent will say, okay, we can finish with the operation, and it will respond with a message without any tool call and with an end message. All right. So now I will execute this. So you have still the human message. Okay, I forgot one thing is to bind the model with the tool. So for this, we need to have like this just model bind tools, and you affect the model with all the tools as a collection of tools for an capability for the agent. And here we call model with tools.
That's just basically to make LLM aware that which tools are available with it.
So we have the message here. Behind the scene, we have delegations that are signed off chain, and then you see the AI message where you see tool calls. Okay, and if you go down, you have tool calls and the list of tools that needs to be called. So here it's required a transfer tool call with those parameters. So everything has been called, and you see that all the transactions have been successfully executed on chain, leveraging our delegation and using bundlers for the delegations.
Do you want to show Langsmith?
Yes. So Langsmith is a monitoring tool of LangGraph. So it shows all the reasoning of the nodes, because here we have just one tool and one model, but we can have like many tools and many models that call reasoning models that call each others. But here you can see how it looks like.
Yeah, so it's basically giving visibility of what's happening behind the scenes. Like, especially that's a challenge with multiple nodes talking to each other. It can go into the loop. You don't know what kind of prompts are being used for the communication between the agents and nodes. So Langsmith is the tool provided by LangGraph. It just, you have to add the keys and it will just start working. That's one of the reasons that's another good point of using LangGraph. You don't have to code much about it on it. And as you can see here, you can go through like how many tokens are being used. You can go into the details, metadata, all kind of prompts, system prompts, AI prompts, AI messages, human messages, everything is listed. And it's quite helpful just for, checking to make your prompt better. You can go through it and revise your strategy. Yeah.
Yeah, so here you just have the model that calls tool, and then you go back to the LLM that say, okay, I have everything I need, so I go to the end of the process. All right. Behind the scene, we have used delegation. So just quickly. So here, when we invoke the agent, we provide a message of a human. So here it's hard-coded. Then we will see how we can send it with HTTP, but it can be coming from Telegram or any kind of source. And then we provide in the state a signed delegation. So here we just sign the delegation. So basically, to sign a delegation, you just create a smart account. So here we used MetaMask smart account. So we sign it with the private key of the user. And we create a delegation here with a scope. So here we have a scope that is named native token transfer amount. So the agent that will receive this delegation will be only able to do a transfer with a certain address. So here we have just one address that is possible to send. And we can add like a lot of conditions. We can have a maximum amount. We can have like a periodical allowance and so forth.
Yeah, so basically, you can achieve a granular level of control over what kind of transactions you want agent to perform on your behalf. You can set a limit on your, let's say, token amount. You can even restrict number of executions per month. You can even restrict, let's say, only these transactions can be only done by a particular Uniswap address. So yeah, it can be granular. It can go to a very low level. So that's the power of it. Yeah.
Yeah. So this is like the first delegation. So maybe let's see it with like an example with a diagram. Okay, Satya, I'll let you explain the first part.
Yeah, so in there are different varieties of smart accounts. MetaMask has a one way of implementing it. So in MetaMask delegation toolkit, MetaMask smart accounts, there is some part which is off chain and some part which gets executed on chain. So delegation is the main part where it's like a signed permission, like I allow user to execute transactions on my behalf. That part is this permission. So this is composed of like from which user and to which address the permission is given. Then user signs that delegation, but it can be kept off chain basically because it's a signed thing. Then you can see another delegation that's to show the capability of chain of delegation. So one example could be I allow my agent to perform pay for my subscription on Netflix or Amazon. So Netflix and they will have their own agents. So it's kind of a chain of delegation. So I allow agent to give my delegation. It can give transfer my subset of delegation to various other agents as well. So that's that can be achieved using the chain of delegation. So here you can see there is a reference to the parent delegation and the permission, which is a different, it can be a different permission, it can be a subset of permissions. And then from agent 1 to the agent 2, and agent 2 is the last end user who will actually use the delegation. So that actually creates a user operation. User operation, I think, yeah, Dayan will explain. That's the on-chain part.
Yeah. So in our use case, we have the users that delegate over transferring if from its account. So when a delegation is sent to this agent, the agent can transfer if from the user account. And when you look at the block explorer, you see that it's the user that sends the transaction. But behind the scene, it's the agent 1 that triggers the operation, sends to the delegation implemented in the smart account of the user. And then the agent 1 just can redelegate, and for redelegation, it cannot delegate more than the initial permission. It can do the same or a little or less. So if the maximum amount is to transfer one if, it can transfer like 0.5. Say, okay, the final agent can just transfer 0.2 if, for example. Okay, and the user op is like the transactions equivalent for a smart account. So the agent 2, in our example, has a smart account. So it will send the transaction, so user op, through the entry point. So in each blockchain, you have an entry point for smart account verification and actions. So here, the agent 2 smart account will verify that the agent 2 is the owner of the smart account. And then it calls the delegation manager that will be the smart contract that will enable to execute from the agent 2 smart account the operation on the user smart account. So yes, here you have all the chain of delegation and all the process end-to-end. So in the code, we have seen like the delegation part from the user perspective at the beginning when it sends the message to the agent. But if you go to the tool, here what we are doing is that we are retrieving the signed delegation. So we have the parent delegation, and then we can on top of this, create a transfer delegation. So this is a second delegation. So it's the same operation, but for the chain. And then we call the external agent that will do the final transfer. And we send the 2 delegation in order that the agent 2, this one, will execute the final operation.
So all the magic happens in that bundler thing where the transactions are submitted via entry point and the validation and everything happens inside, and then actually the transaction is executed on behalf of user.
So now to make it more production ready, we will launch a server. So here you can directly go to the agent service. And here you have all the endpoints that we offer from our agent. So basically, it's just an Express server, and we offer like an agent card. So in A2A standard, agent card is the card of the agent describing the endpoint to access to this agent, the authorization, authentication method that you need, the skills that are available, the price, and so forth. And agent URI is like the metadata that we will push to the ERC 8004, so the identity registry. And then we expose like several services, so free service, paid service, and as example, MCP and A2A endpoints. So if I go to the agent service, you can see that you have the different endpoints. Okay, I'm going down. So basically, it's just the Express app, and then we just do some get REST endpoints for card, for agent URI, and then we have like post for actually using the agent. So here we'll show like just two endpoints: the free service that are accessible for anyone for free, and the paid service where we will put X402 middleware. So the server is up and running. So I can do a HTTP request. So for example, I will use this curl command. So this curl command is just calling with a post HTTP request the free service, and we just put in the message to send some if to this address. So behind the scene, it will be exactly the same execution than the test. It's just that here we can change the prompt. To make it a little bit more interesting, I will add here. So I'm going back to my runtime, so agent runtime. So here it's my state graph with all the pre-prompt and so on. And I will add new tools. So today we just put the transfer tool. This is actually working, but we mocked some other tool. So we have swap tool, staking tool, yield farming tool, lending tool. Up. So I will import all those tools functions. So if I go back to to the tool, so it's just a collection of tools. So we saw before the transfer tool with all the logic, and then we have swap tool. So here, if you want to play with the workshop after at home, you can just try to implement the swap tool, and basically, so same for staking tool and so on. And basically, the agent is just reading the return message. So if we put it's successful, the LLM say, okay, it's successful. So it's easy to mock. So here it will, if we ask to do staking, since it's returned successful, it will just return the message. So if I do this, so I will ask to send if to this address and stake 5 if on mainnet, and to to lend 1,000 USDC, and to yield to do the best yield farming transaction in a liquidity pool. Okay, and I will show after in Langsmith, so you will see all the tool call and so forth. Okay, so the tool have been added, and now here we see like everything that is being called. So you see the different invocation. So I will go to Langsmith. It will appear. Maybe this is this one already. Okay, so he called like several times the same tool. Let me see why. Agent runtime. Okay, I will just put this like this, and I will re-execute. I know why, because I didn't restart the server, sorry. I did the same error in our test before. Okay, so I will restart the server because I changed this, but I keep the server live. So now, okay. Suspense. Okay, so yeah, you see that I can see on my message here that it's calling the different tools, lending, yield farming, and so on. Okay, it's a lot of comments, but here you see the initial human message, and here you see all the tools that have been invoked, and basically in each AI message, it was a new tool call. Either, depending on the reasoning, it will be like each tool in parallel or each different tool recursively. Okay, so I'm going back here, and here it will refresh. I believe it's this one.
Can I ask?
Yes, sure.
We added the tools as nodes, right, to the line graph. What is the conditional edge actually doing in this prompt situation?
Yes, okay, I will show you that. So here you can see like that the agent has called all those tools, and at the end here you see the message that okay, we have stake 5 ETH, okay, we have learned this and this. So you question, okay, so the conditional edge here is quite simple. It's just taking the last message. So if we go back to the loop, in the workflow, so the model have the prompt with like all the things that it needs to do, and it will first call it will say, okay, I need the transfer tool, but just the transfer tool. So in the conditional edge, it will look at the last message. The last message will be AI message with like metadata requiring transfer tool. So it will call the tool node and will just call the transfer. It will be done. Then it will go back to the LLM node and it will look at the state again and say, okay, the transfer has been done. Now I need to stake. So it will go to the conditional edge and we will have the tool node stake, and we'll go back to tool node. The tool will do the staking thing and we'll go back here, etc., etc.
So it identifies the prompt in like an array of tools.
Yes, exactly.
Yeah, the line graph actually, if we are using the tools provided by line graph itself, this probably is not required because it knows the tools which it has. But because we are using custom nodes, we can add some custom logic. Okay, this means this, transfer means transfer node. So that's the reason, yeah. When we add tools to LLM, it already is aware of what tool it has. But if it's a properly named yeah. Yeah, because then it will only choose two. Yeah. In the order as well, yeah. But it depends, like how specific prompt you want to give. If LLM is not good enough, the model is not good enough, it probably won't perform well because it's ChatGPT. Like it is understanding those things in sequence. But you can control that as well. If you want to use like a, let's say, smaller model, maybe your prompt has to be a little bit specific. Like if these are the tools available. If user asks transfer, then use this tool. Yeah.
Yeah, the reasoning layer is really deciding the way the tools are used. For example, you can ask, okay, can you transfer this token to this chain with a swap? And it will automatically see, okay, I need to use bridge first, and then I need to do a swap, and so forth. So the reasoning layer will be able to do it if you have, like, it depends on the quality of the model, but also the quality of the prompt and also how routing is implemented.
So if you have to do any form of cross-chain, does it have to happen at the tool level, like a separate tool? Or?
I would say that if we need cross-chain, we would need to have an additional bridge tool that will do the bridge between one chain to another chain. And then we need to have like swaps that are working for the chain, the target chain.
So essentially another tool, not just the swap.
Yeah, exactly. Yeah, actually we have many tools, and then the agent do his magic by using the right tool in the right order.
So is this different from the X42 layer, or that is independent of that?
From the what?
X42 layer.
Ah, yes, it's different, and this is a good transition.
Yeah. So actually, X402 is completely used for different purpose. I mean, this thing is explaining basically how delegations can be used for bridging and I mean any blockchain operations. X402 is on one layer above. It's in the middleware. I mean, I think Dan can explain it through the code itself.
So going back to the code, so I mean my Express server in agent service. Let's say that we have the paid service. Today, it's not implemented with X402. So what we need is to create a middleware that will intersect the call, the HTTP call that will be enforced here with X402 and interact with a facilitator. Okay, I will show you the diagram. So here the client is the user, the entity that will send the HTTP request. So for example, here we have the paid service that is a post HTTP request. Send it to the server. The server has a middleware that say, okay, this endpoint needs to be paid in order to access the service. So you send a response message with the code 402, and in this 402 response, you have in the header a X payment field that will say that will give all the information about the payment, how much, which chain, and so forth. Once the client have received this, he can send the request with the X payment header full field, and in this X payment header, it will be an off-chain signature that will be ERC 3009 authentication. So there, behind the scenes, it's a P712 signature that is usable in ERC20 token with the function transfer with authorization.
So another slight explanation on it, like in this example, particularly X402, let's say imagine I'm developing a few agents and I want to deploy it and I want people to use it, but I don't want to give it for free. I want to charge, let's say, $0.01 for each request. So this example shows basically we can use X402 payment in that and collect some fees just to pay for the services we are providing. So behind the scenes, what in the code what we showed is not related to the X402. That's a completely different thing. Just to clarify the confusion.
Yeah. So what I'm going to code now, it's the server that is having a collaboration with a facilitator. So it's a trusted entity for the server. So the server has nothing to do. Just finding a facilitator. The server will say, okay, I want to receive 0.01 USDC to this address. It will be send the request to the facilitator that will check that the signature is correct, send to the right address, and will then execute the USDC contract and send the response to the server. The server can check if it wants, and then fulfill the service that is offered by the paid service in our case. So going back to the code, so I have the paid service. So today you have like SDK that enable to implement that really easily. So in Express, for example, you have like a solution that enable to do it with few lines of code. So you have app.use, and you have this object that's a payment middleware. And the payment middleware will have in parameter the address on which you want to receive the payment. So I have the target address, and then you provide the endpoint on your Express server, the price you want to make it payable, the network, and the information for in the HTTP request for interpretation. Okay, so now we have the middleware, and normally, if I try to call this request, I will have the X402 response. So I will restart the server.
Check the target address if it's added.
Yeah, thank you. Yeah, it's good. It's just want to type.
Yeah, it's okay.
Okay, I know. So, okay, target address as. Okay, now we have a type. Awesome, thank you, Satya. So I will restart the server. My server is now running. And what I will do now is just to call this endpoint, so paid service. So the same as we have done before, but paid service. Empty reply from server. Okay. I think we have problem with the pay to address because it's not pay to address.
I think there are 3 minutes left.
Okay, 3 minutes left. Okay.
Shall we do
should
QA?
Yeah,
Q&A.
We conclude. So I just show you the request, and then we.
Yeah.
Okay, so it's just the wrong one. Let's finish with a positive note, with something executing correctly.
Yes.
Okay, it's here. So here you have the X402 headers that say, okay, I require to pay, blah, 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 blah. And then you can, we have like something implemented that pay automatically. Okay, so it's this call service. And here we just pay USDC and it's calling correctly the endpoint. And everything is done. It's under the hood managed. Okay, so it's all for X402. And the last thing, so we will not go into detail, it's ERC 8004. And here, basically, we have 3 registries: identity registry, reputation registry, and validation registry. And here, so you can play with the workshop at home, so it's the last step, agent registration. So here, basically, we are just registering the agent. So to do so, you call register, and this will register the agent on chain. So there is an SDK that is really convenient, that is agent 0. So we provide like the information, the private key and so forth of our agent, name, description, and so forth. And then everything is registered on the registry, and then the agent is discoverable. So you can see the chain ID and the ID of my agent. So it's 3336 on the testnet. And here you can see information about the agent directly on the Explorer. So there are Explorer that enable to see agent information and so on. So that's it, basically, right in time. So just to conclude, so I will show you again the repository QR code if you want to play with it at home. Okay, there is a trust execution environment. We will not go in deep inside this one, but it's about enclave and verification, and you can send the verification to the ERC 8004 verification registry. So this is a repo. So you go to the README, and everything is explained step by step if you want to play with it. And you have the slides if you want to use the slides. It's a PDF. It's not the last version, but it's a good version. Okay. Satya, if you want final words or anything.
Yeah, thank you, everyone. I mean, yeah, it was a good. I mean, we had so many things to. We tried our best because we tried to cover so many things in a short time.
Yeah.
So sorry if we have missed anything or confused you guys. Yeah.
Thank you.